Today's notes are going to cover biconditional statements. Consider the conditional. If 3 points are collinear, then they lie on the same line. Is this conditional true or false? Well, by definition, collinear means they lie on the same line. So this is true. Let's write the converse. So yesterday we practiced this. And when we're writing the converse, we switch. So let's identify hypothesis and conclusion. So our converse is if they lie on the same line, then 3 points are collinear. Is this converse true or false? Well, if they're on the same line, by definition, they are collinear. So this guy is true. Biconditional statements are written as P if and only if Q, or P implies Q, Q implies P. A conditional is a biconditional statement whenever both parts of the statement are true. Both the conditional and the converse have to be true. So let's take a look at another example. Given the following conditional statement, determine whether it can be written as a biconditional. If it is a biconditional, then write it as a biconditional. So our conditional statement, if 2 angles have the same measure, then they are congruent. There's our hypothesis and conclusion. Is it true or false? Well, if 2 angles have the same, they are congruent. That's true. So let's write the converse. Converse, we switch. If 2 angles are congruent, then they have the same measure. Now, is that true or false? Well, if 2 angles are congruent, congruent means the same, then they have the same measure. That's true. Both the conditional and the converse are true, so this is a biconditional statement. Now let's practice. Go ahead and pause the video and work through these 3, and then come back and check your answers. Okay, number 1. If you visited Denver, then you've been to Colorado. Well, that statement is true because Denver is in Colorado. So the converse, where we switch the hypothesis and the conclusion, if you've been to Colorado, then you've visited Denver. This is a false statement because you could have traveled to Colorado and not visited Denver. So since the conditional statement's true and the converse is false, this is not a biconditional statement. Number 2, if you've been to the Gulf of Mexico, then you live in Texas. Well, you could have traveled to the Gulf of Mexico without living in Texas, so this guy's false. Now the converse, if you live in Texas, then you've been to the Gulf of Mexico. Well, this one's also false because you could have lived your whole life in Texas and never visited. These are both false. This is not a biconditional statement. Number 3, if an angle measures less than 90, here's our hypothesis, then the angle is acute. Here's our conclusion. That is true. Angles that are less than 90 are acute. The converse, if the angle is acute, then it measures less than 90. That is also a true statement. So this is a biconditional statement. Let's take a look at number 4 together. If an angle is a right angle, it measures 90. That is true. The converse, if it measures 90, then it is a right angle. That's true also. And this is a biconditional. Number 5, if you are a geometry student, then you are a math student. Well, that is true. But what about the converse? If you are a math student, then you are a geometry student. Well, that's false, because you could be in an algebra class. This is not a biconditional. Are the following biconditionals? If not, provide a counterexample. So in number 6, if two angles measure 170 and 10, then they are supplementary. This is our conditional statement, and that's true. Because remember, supplementary angles add up to 180. So let's see about the converse. Let's switch. If two angles are supplementary, start with my conclusion, then they measure 170 and 10. Can you think of two other angles that are supplementary that are not 170 and 10? Sure, how about two 90-degree angles? Those add to 180. Those are supplementary, but they are definitely not 170 and 10. So this is false, and here's my counterexample. Number 7, if it is Christmas, then it is December. Yes, because Christmas is in December. Let's take a look at the converse. If it is December, we're going to switch, then it is Christmas. Well, as much as we love Christmas, it doesn't have to be. It could be December 2nd. This guy is false. And here is December 1st, December 2nd, December 3rd. You could list all the other days in December that are not Christmas. This is my counterexample. And the last one. If you pass the exam, then you score a 70 or higher. Well, that's true. A 70 or higher is passing score. Let's switch. Let's write our converse. If you score a 70 or higher, then you pass the exam. That is true. If you score a 70 or higher, you pass the exam. Since these are both true, this is a biconditional.